Alright, so we're going to continue with word problems here. And number 7 on 1.9, this is from the notes. We have a baker who is selling cookies, and it says 12 cookies for $11.75. Now I have to pay attention to what this is asking me to do, because I'm not actually going to use this in my equation. I'm going to use parts of this. Now it says that the cost of those was $11.75, so I just really need to know how much is she spending. And it says plus, you've got this 23-cent charge for each additional cookie. So if I'm setting something up, I would set it up like this. How much is she spending? Well, $11.75 plus 23 cents per cookie. And they also tell us that she has $13. So I know in total she has $13 to spend. So I really did not need to put this 12 in my equation at all. It doesn't affect the outcome here. So she's going to be spending $11.75 for that first box, 23 cents per cookie, and this is how much she has to spend. So all I have to do here to answer this question is solve for C, and this is a basic two-step equation. I'd subtract $11.75 first, because she's spending that much right off the bat. She's spending $11.75. So I need to know how much is she going to have left over when she has spent that $11.75, and then so she spent $11.75 of the $13, and that leaves her with $1.25, and she has 23 cents per cookie now that she's going to be spending. And if I divide both sides of my equation by 23, because that's 23 times C, I get C equals 5.43, and it's this crazy number that just kind of keeps going on. Looks like an irrational number, and it just keeps going. All right, now we have to answer this on a test. It's going to ask you for just the number. What's the maximum amount of cookies that someone could buy? Well, you can't buy 0.4 cookies. If you go and ask for 5.434 cookies, they're not going to give you that. The most she can buy is 5. She's still going to have a few cents left over, but not enough to get that extra cookie. So my answer, when it asks for me to type this in on a test, would just be 5. So just make sure you're paying attention to what the decimals are, what they actually mean. Doesn't make sense that you could buy 5.4 of something. All right, now here is an equation that has dollars in it. We usually just use whole numbers in our equations, but we're going to be seeing decimals from now on. So here we have a store selling cookies, and it says the first dozen was $4, and each dozen after that was $3, and they have that shown here. All right. Samuel bought cookies for a fundraiser for his golf team. He spent $58. That's why it says this equals $58. How many did he purchase? Now this should give us a whole number, because if he spent $58 and that's the equation, we should end up with an actual whole number here. This is just a basic equation where I'm going to follow those steps, and if you remember the steps that we followed, we distributed first, okay, and then we would combine like terms. Then we would make sure the variable's on one side. So here I would distribute 3, and I don't need to put 4.00 or 3.00. If I'm working this out, there is no change. So 4 plus 3 times C minus 1 equals 58. It might be easier to look at it like that without the decimals, without the cents, because there was no change anyways. So I can distribute the 3, and that gives me 3C minus 3, and then I'll just bring everything else down. 4 plus 3C minus 3 equals 58. Now combining like terms would be our next step in solving this equation, so I would combine the like terms. 4 minus 3 is 1, and then just bring down everything else. Plus 3C equals 58. Now I'm solving an equation. Order of operation goes in reverse, so I would take care of the plus 1 first. I would subtract it. So that's going to give me 3C. 3C equals 58 minus 1 is 57. And my last step would be to divide by 3. And that's going to give me C equals, and I know 3 goes into 60 20 times, but 57 is just one less than that, so it's going to go 19 times. And that is exactly how many dozens of cookies that he purchased. Alright, now this is a very common example of an inequality, something like you might see on the test, where you have two scenarios. Alright, I just need to get these two scenarios separate here. I've got two jobs. Michelle is applying for two jobs. She wants to know which one pays more, or what would it take for one to pay more than the other. It says as a hostess, she would make $480 a week. And that's it. She doesn't get tips. So in one scenario, she's going to make $480. Now she's trying to compare that to what she would make as a server. And obviously, when you sign up for a job, go back here. When you're signing up for a job, you want to know which one is going to pay more. So she knows she's going to make $480 as a hostess, but she wants to know if she was a server, which is only going to make $370 a week. It makes it less. But she gets to add in whatever she makes in tips. So you've got $370 plus tips. That's one of the jobs, and the other one is just a set $480. That is all that you're going to make at that other job. So what she needs to know is what inequality would show. Now it says which inequality could be solved to find T, the weekly tips Michelle has to earn in order for the server job to pay more. So I need to look for keywords here. Inequality. I want server job to pay more. So if I'm going here, server job right here, I want the server job to pay more than the hostess job. That's my key. So if I look at what these represent, 480 was the hostess job. 370 plus tips was the server job. So I need to make sure when I look at my inequality, what does it say? It says she wants the server job, which is what this is right here, to pay more, which would be greater than. She wants the server job to be greater than the hostess job. So I need to find the inequality that actually says that. And this is just like what you'll see on the test. There'll be two different jobs. Which one pays more, the hostess or the server? Well, I want the server to pay more, so that's why the server job needs to be greater than the hostess job. So we'll look at the scenarios up here and see which one says that. In this one, it says the hostess job pay is greater than the server, so it's definitely not that. This one says the hostess job is less than the server job, and that's what I want. I want the server job over here on the right to be greater than the one on the left, and they actually have it set up correctly. And you'll notice an example just like that in the homework. And here's also, this is another good test question where you have two scenarios. You got one swimming pool with 400 gallons of water. Then you've got this other pool that's double that. Actually, it has 800 gallons of water, and one of them is losing water. This one over here is losing water. The 800 gallon one is losing water. The 400 gallon pool is gaining water. It's filling up, and they tell us that. They say that the first swimming pool begins to fill up at a rate of 4 gallons per minute. So this one started at 400 gallons and it's filling up. They're adding water to that. They're adding 4 gallons per minute. The other one started out with more water, but they tell us that the second swimming pool starts draining. In other words, losing. If I'm draining it, I'm taking away, and it's 8 gallons per minute. That's how these two compare. They say which equation can be used to find the number of minutes X that has elapsed before the two pools have the same amount of water. When will this pool equal this pool? Okay, well, I just set that up. I just used two expressions to compare them, and I want to set up an equation to show when would they be equal. Okay, so the one that had 400 is gaining water, so 400 plus something. But the one that had 800 was losing, so I definitely know it's not that one. And if we look down here at the bottom, choice D, it says this one has 400. It's gaining, just like the example said. If it's 400, it's going up. The one with 800 should be going down, 8 per minute. Okay, so it has to be D right here. These other ones, this one's going up and down, but they have like parentheses. If I distribute this and try to make these look like they represent the problem, it's not even going to be close. Okay, because then I'd be saying it's losing 400 per minute, and that's not correct at all. And same thing here. These are both plus anyway, so I know those aren't right, because one of these pools has to be draining water, it has to be losing, and one has to be gaining. Alright, now this question relies on vocabulary. This is an equilateral triangle. I have a triangle that is equilateral. You need to know what that means. Otherwise, this question is really not going to make sense. An equilateral triangle has 3 equal sides. So if this side is 10, they're all going to be 10. So I need to know what an equilateral triangle actually is. Now, they give us an expression. They don't give us the side length, okay, of any side. They give us an expression, though, that represents the sides. They tell us that one side of this triangle AB is 5x. The other side of it is 3x plus 12. Okay, and that's what that means. That this triangle, basically, they have labeled it A, B, C, and they're just telling us that side AB was 5x and side BC was 3x plus 12. Well, we need an equation. If we're going to solve for x, we need an equation. And an equilateral triangle, I can easily set up an equation because I know that this side is equal to this side. So that's how I'm going to set up my equation. I'm going to say, well, 5x is equal to that other side, 3x plus 12. Well, now that I've set these two sides equal to each other, I have an equation that I can actually solve, and I can get a number value for x, and that's what I need. X right now is unknown. I need to figure out what this is so I can find the perimeter. Well, I need to get my variable to one side in this equation. I have an x on both sides. I will subtract it. 5x minus 3x is 2x. And then that 12 just comes down. Now I would divide by 2 on both sides, and this tells me what x is. Now be careful here. X equals 6. They did not ask me to solve for x. They asked me to find the perimeter. So 6 is x, but that's not the perimeter. I'm not adding all 3 sides and getting 6. But I do have a number now, 6, that I can plug in for x. This side of the triangle here was 5 times x. Well, I now know that x is 6. Right? And I just need to know 5 times 6 is going to give me 30. Well, if this side is 30, this side's going to be 30. And if that side's 30, so is this. It's an equilateral triangle. So once I figure out what one side of the triangle is, I know that they're all going to be exactly the same. So the perimeter, by adding up all of these sides, 30, 30, and 30, my perimeter is going to be 90. Okay, this is very similar to the homework questions and the test questions. Just pay attention to what the question is asking. It's not asking for x, and that'll be a wrong answer choice. You'll go, oh, x is 6, I'm done, and pick 6 as the answer choice. Make sure you look at what is this question asking you to do with that information. I figured out what x was, but I had to plug it back in to figure out how big this side was. Then I could add all 3 sides up and get the perimeter.